Chemical analysis of historical crystals revealed a meteor collision that took place 2.2 billion years ago in Australia. This collision means the oldest collision ever discovered. When the meteor crashed into our planet, our world was covered with ice. According to researchers, the cloud of water vapor released into the air after the collision might have acted as a greenhouse gas, heating the entire planet. The researchers studied the crystals in the samples taken in the Yarrabubba collision zone, 620 kilometers northeast of Perth, in 2014. As a cause of the collision, a 7-kilometer meteorite is thought to hit Earth, but the 70-kilometer crater, which has been extremely eroded, remains a fundamental abnormality in geophysical measurements. Almost nothing can be seen on the surface anymore. Chris Kirkland, a geochronologist at Curtin University, based in Perth, is one of the authors of the study and says, "Australia is the place you think. Kangaroos and emulas run in a very flat, desert-like structure." Kirkland et al. Imaged the grains of zircon and monazite smaller than the width of the human hair. Their purpose was to see if the crystal structures were deformed after the meteor collision. "The grains look beautiful," says Kirkland. "There are surface patterns that can occur under extreme heat and pressure conditions. The only way to do this on Earth is to collide a big rock with another big rock. There is trace amount of uranium in zircon and monazite, so researchers wanted to see if radioactive decay products would appear in some of the grains deformed by meteor impact by sending a narrow bundle of oxygen ions to the samples. We were able to calculate the age of the collision by targeting specific regions within the crystals that have been reset by the collision event," says Timmons Erickson, a geochronologist at the Houston Space Center, NASA, in the USA. The uranium isotopes in zircon A and C and monazite B and D proved to be the oldest region in the world. The collision 2.2 billion years ago was 200 million years older than the collision zone at the Vredefort Dome in South Africa. Vredefort Dome was the oldest collision zone before the collision area in Australia was found to be age. At the end of a process with excessive icing, the Yarrabubba meteorite is thought to end this period. The collision might have melted an old ice sheet and released 5 trillion tons of water into the atmosphere. Erickson sees it as an event that will change the chemistry of the Earth's atmosphere and has the idea that it maintains today's mild weather conditions. Kenneth Amor is a geochemist working at Oxford University and thinks that the crash date suggested by Erickson and his friends is reasonable. He was not involved in the work of Amor Erickson and his friends, but was the leader of the team in Scotland, who discovered the largest meteorite that hit Britain 1.2 billion years ago. Amor finds the view that the water vapor cloud in Yarrabubba warms the Earth. However, he says, it seems unlikely that if the effects last only a few years, it will not cause the ice to melt, unless the melting of ice has already started. While Erickson and his team's research identified the oldest known meteor collision, there is another study that found the oldest substance in the world in a falling meteorite in 1969. By measuring the neon isotopes formed by exposure to cosmic rays, it reached some silicon carbide grains formed 7.5 billion years ago. 7.5 billion years means that it was formed before the Sun and planets. According to the International Research Team, these grains are part of the interstellar dust that occurred about 5 billion years ago in our solar system. According to the geological findings at hand, until about 3.8 billion years ago, the Earth was subjected to a heavy meteorite bombardment. In the evolution of the world, these impacts have undoubtedly had very important effects. Short-term instabilities in the Earth's crust, increase in volcanic activity, and indirect consequences, as well as changes in atmospheric gas compositions. But altogether, these massive masses of a few tens of kilometers in diameter led to giant craters that were several hundred kilometers wide. But is this bombardment over 3.8 billion years ago? No. This rare natural phenomenon continued. One of them hit the world 65 million years ago from the famous ones, and possibly wiped the dinosaurs, except birds, from the Earth forever. Another hit 1.85 billion years ago in the Ontario region of Canada today and created a gigantic crater. When we look at the surface of the world today, we can detect some of these impact craters very easily, but we can find it difficult to find some, even some of them larger. The reason for this is that the world is a dynamic planet. Processes related to inside the world, such as continental drift, volcanic activities, as well as processes related to the extraterrestrial, such as streams, winds, glaciers, make it difficult to detect by filling and filling impact craters. The specificity of an impact crater varies depending on the time of the impact, the dimensions of the meteorite, the impact zone and the activity of the geological processes in the impact zone. Today we have discovered many crash crater. You can find the location of the 50 most prominent of them on the Google Maps map here, and you can zoom in to see satellite images of these craters.